I'm Joan Codina. I'm from here, from Barcelona. I'm from Barcelona Media, which is an innovation center. And I'm going to talk about how we adapt Ajax-Solr to drill down documents and compare different sets of documents. What I want to tell is that Solr has Facets, which is a very good tool for knowing what is on the data, but they are just Facets. Yeah? They give the information that they give. And when we do research on opinion mining, we find that just having Facets, it's not enough. Why we do, or what we do when we do opinion mining? Well, we try to give an overview of thousands of opinions. So there are thousands of opinions, and the people on the companies want to know what's on that opinions. And we want to make some presume, to give some cues about what's on there. We do it with a team of people who comes from the computational linguistics. So they do natural language processing. And once they explore the data, they extract the information. We need, well, they extract the key concepts expressed on the text. So they find name entities, they find the nouns, the verbs, the adjectives. They found chunks of nominal chunks. And we can extract them from the text. But then we need a way to explore where they appear, which concepts they appear. And the key question is, what we want to know? Which are the most common ones, or the ones that differentiate the opinions from one company to another company, from one part of the society, from another part of the society, from people from one country, from another country, by gender. And the idea is that we used Solr and Ajax just at the beginning to see the data, to see what was on the data, because after you crawl a place or you get a lot of data and you have to analyze it, the first that you have is, OK, what's inside? And we saw that just looking at the data was not enough, but we need something else. I'm a senior researcher. I do my research in Barcelona Media, which is a company, well, a company. It's an innovation center. It's a non-profit foundation that makes technology transfer from the university to companies. And my experience, my background, comes from the mining, from data, then text, then web, then opinions. Yeah, I started with data mining some years ago, and then we moved to text. The text was from the web, so we moved to web mining, and now we do opinion mining. When we do opinion mining, well, every time I think the data is more and more noisy. When you get data, the data is very nice. You get a database, and everything is perfect. Well, more or less. Then you get text. Well, text is not so perfect. Then you get into the web. Well, a bit more noise. And then you get to the web 2.0, and everything is noise, and you have to find something between the noise. The noise, it's bigger. There is a lot of more problems than with raw data for preparing, for processing, and all this stuff. And we work with an interdisciplinary team where we integrate the tools of natural language processing. Also, we do some multimodal search, and on some spare time, I do some teaching. So the challenge is that when we do opinion mining is that companies, big companies, they have a lot of noise in the network. There's a lot of people opinionating, talking about them. And they need to know what they say. And that's not so easy, because there's a lot of production every day. You cannot read thousands of posts in so many different places. And they need to have an idea of how things are evolving. There are many writers, so many writers, in so many places, with so different objectives, with so different styles. And if you are in the market, you must be alert of what's going on. What's the hot topics? What's people interested in? What's people saying about your company? What's the most important thing why they change, for example, from one mobile company to another? The price, the quality, the service you give? The people who moves, what they say before moving in the network? Because they was too expensive or because they found and nobody answers them or didn't solve the problem they got. We use natural language processing just to detect the important parts of text. When you get text, you have to find the companies, you have to find the key concept they are talking about, and we use natural language processing for that. But, as I told you, user-generated content is noisy, irony, and a lot of other things that make it a bit difficult. Irony is one of the most difficult ones, yeah? Because a very, very good opinion, when you read it, say, okay, maybe it's not so good. It's just the other way around, yeah? But you can have this impression when you read it. But for a computer, that's very much difficult. And the key concept is we want to go from data is text in our case, to information. Information is something more elaborated. And from information, we got to go to acknowledge. Data mining is more in this step, from information to acknowledge. And we are going to talk about more from data to information. A bit, for us, it's the first step to analyze the data before doing opinion mining or text mining. So let's put an example that we are going to see some data afterwards. We want to analyze the users in MySpace. Well, why MySpace? Because we did a crawling some time ago when MySpace was still MySpace. Yeah? And from MySpace, you can get a lot of data of demography, not only what people write in the forums, what we crawl, but also the demographic data of the people. So we know the age, the country, and gender, and etc. Once you get this, you can navigate through the data. We built a Solr index, and we could navigate the data and try to find the important things on it. But we saw that just moving around was not enough. Why we do that? Well, the first thing is, before doing any other processing, is to look at the data, to see which kind of data do you have. It's just before to do a blind automatic, well, it's not just before, it's to avoid to do a blind automatic text mining. Yeah, if you take a text mining tool, you have to set a lot of parameters. And most of the time, when you think on text and text mining, you have a lot of words. So you have a big matrix that every column is a word, and then you have the set of documents. You have a problem of dimensionality, and you have to carefully choose the right words to try to reduce the size of this matrix. Before doing that, you must know which is the kind of text you are in front of. And this is a good way to do it. Just put the data into Solr and explore it. First, you must get some acknowledge, just to tune the text mining tool. Yeah? Just not to be a blind and automatic process. Because if you do that, the results usually are average. Yeah? You will not be able to get something that says, that's good. Yeah? There are too many parameters, too many words. It's easy to have overfitting. That happened, for example, now. We are in a project, and we have only some thousands of annotated data. If you think, we have some thousand comments that some users have annotated, indicating what is interesting for them, but they have, in these thousands of opinions, there are tens of thousands of different words. So the matrix is not correct. We need to find a way to reduce the number of words, so there are some regularities, and we are able to find some regularities. If not, if we use data mining, the tool will do overfitting. They will say, OK, this word and this word and this word only happens in this when, yeah. But this is not what we're looking. We try to generalize. So the idea is that maybe we could have what in data analysis we call an OLAP, yeah, a cube, a way to see the data and to extract some basic statistics. So we have Solr, and Solr is very nice because it has the facets. And if we use facets, a facet is just like a select. If we have a field like age and we use facets, it's like to do a group by. But Solr does that for many, many fields and very fast. That's an advantage. But when we have a text field, that's more complex. It's not easy to do that on a database, yeah? Because we get every word, how many times it appears as a result in a query, of a query. Facets are not IDF, just it's a basic statistic. It gives us the number of times a word appears in a result set. And just is the way around of IDF. IDF gives us, as most important, the words that appear less in a document set. So this is the other way around. The most common facet is the one. So the most common facet is the ones that appears first when you do a facet search, and is the ones that give less information because are the most common if we think an IDF. But the rare ones are not useful. So if we think on frequency, this is a word that appears in any document, and this is a word that appears in all documents. A word that appears in all documents gives a few of information. This is the idea of IDF. And facets is just the other way around, yeah? But also these words here. So these words are the hapax, yeah, the words that appear once every few documents. And even that, from the point of view of IDF, they give a lot of information. Statistically, they don't represent much data. They are not useful. All the mistakes, yeah, strange names, they go here. These words that appear 1, 2, 3, 4 times in a big corpus. And they are a lot, yeah? As the power law says, we will find much more words here and only a few in this side. But we are interested in the ones of the middle. If the yellow line indicates how much information do we get from the words. And I think that the ones that are in the middle are the ones that will give us more information. The information, we could say, it's not in the two common terms, not in the two rare. It's in the not so common terms, yeah? Something in the middle. Let's do a search. We do a search, and we get a result. And from the result, we get a set of facets, yeah? That say, OK, this is the words that appear in the opinions, in the documents that you have selected. But if we do another search, and we look at the most common facets, we are going to see that they don't change very much. Because when we get the top ones, there are those ones that were in the right side, and there are the ones that appear everywhere. So if we sort them by frequency, we are going to see that we always get more or less the same. And it's difficult to see if there have been changes. But maybe what we are seeking, well, the information we need to know, it's not the frequency of the terms, but how this frequency changes. And this is a bit what we do. So let's see an example. Let's imagine that we are looking at MySpace. We have content. Here are the top facets in the content. We have gender, country, and age. And, well, age is sorted as text, so we have 100 and 105 here. Well, this is the people that don't say the age, so it's the default. I think it was about 1900, so we have some of these people here. And this is with no query. Yeah? This is the most common word after removing some stop words. So the people that appear here, the words that appear here are words which are not stop words, or maybe like Q. This is in Spanish, yeah, because we did a crawling of MySpace in Spanish. So this is the Q is an abbreviation of que, which means what, yeah, but it's bad written. It's just a simplification. It's the same like que, this word and this word as a chat speak of que. Yeah? So this is the list of most common words, and you read that and you say, okay, nice, well, some words. They don't say nothing interesting. And those are the countries: Mexico, Spain. Mexico is the most common one, Spain, the US, and then there are some US states. And the most common age is about 20 years. So let's make a query. Yeah, we have make a query, and we have Mexico. So we have selected Mexico. And here we get the top facets, and the top age, and the gender. And we make a tag cloud. And we look at the tag clouds, and the problem is find the 10 differences. Yeah? Which is the difference? Okay, here it's bueno, there is bueno, there's ahora, here it has disappeared. Que, maybe it's a bit bigger. I'm sorry. Here we have the M, maybe M is similar, but the F, maybe it's smaller. 15, maybe here it's bigger. 20, well, more or less, 25. Yeah? But we can do that because we have one and the other. But if we did a search with a single screen, that disappears and appears that one, and it looks more or less the same. Yeah? We don't get many information from here. The ages, well, maybe it has changed a bit. And it happens the same if we say, okay, select all the opinion, all the forum posts. This is our forum post sent by mail. And we do the query, and we have, yeah, male, female has disappeared. And okay, find the 10 differences. Yeah? Well, where are the differences? Okay, we can look now at the countries. Mexico, more or less, is there. Spain is, well, a bit smaller. That one has disappeared. And the ages, we look at more or less the same. But when we look at the words, it's difficult to find differences. Yeah? It looks more or less the same. So we are getting data, which is true, but maybe it's not information. So what we are interested is to know which is the difference between the Mexicans and the rest of the world. Which is the difference between male and female? What identifies the Mexicans? Can I read the text and say, oh, it's a Mexican because from the information I got now, I'm not able to do that. Even if I increase a bit the list of words, yeah? Then it's more difficult to find the differences. So my question is that one, yeah? Which are the terms that use the males or the people from Mexico, or which is the terms that better identify them? We got the solution for the first question, but not the solution for the second one. We must find the terms that best identify them. So the basic idea is, okay, this is the first set of results with no query. Yeah? Current selection is viewing all documents. And this is the result I got from Mexico. This is where we were looking at the differences before. And now we have to know, we have to subtract them. I have to take this list, maybe bigger, and subtract this list. and say, okay, let's see the differences. And here we have, this is the first result, the most used words by the Mexicans, and this is the difference, and the difference changes a lot. The words have changed. And if you talk to somebody to Mexico, they'll say, okay, this maybe Chiales is very, very typical from people from Mexico. The way they write Mexico with yeah, in other places they do that with a G. Como, con, with a key instead of the C. So it has changed. It's different. The list of words is really different. So I can say now, okay, if I see these words, I'm more sure it's a Mexican. Look at the edges. They have changed a lot. Here we have 15, 20, 25, as in the big set. But when we compare with the big set, we say, okay, there are a lot of Mexicans of 65 and 70 years old. There's a lot of about 40. And well, 15, 20, 25, there are some. There are many of 10 years old, not a lot of very, very old people, yeah, very integrated to the new technology. So it's different, yeah, the information I get here is very, very different. This is data, and this is more going to information. The same with gender, yeah, now the F, here it's clear that the F, it's smaller. If I select by gender, so I have male and male, here it's what I saw before, and here is what I get. It's curious that some of the words are from Mexico, because in Mexico there were more male than female, and Mexico was the biggest group of people in the set, but the age is giving some information. There's more males about 50 and 60s, and 75, a few only of 80. Again, there's here those people, so that it's wrong ages usually. And yeah, you see that the not so young men and more middle age. Well, so something has changed. This, I cannot get this information quickly from this data. The countries, Mexico has almost disappeared, and there are a lot of strange countries. Well, usually that can appear if, for example, I don't know which is CN, CX, yeah, but it can happen that only a few people is from here, and all of them are male, so it pushes up, yeah? Here it's more about volume, here it's about differences between sets. Also, we can try to make a double query, and we say, okay, I always want to see males and females. Yeah, the top row are males, the bottom one are females. So every time I do a query, now is without query, I want to see the difference between the two sets. So here I have, for example, the age. So male are about 35, 40, 45, 50, and 1995. And women, very old ones, they have said. They live more than us. Yeah? But I didn't thought the difference was so big. Well, what we can read from here is that usually women don't fill up the data, yeah, the born. And here we see the differences in the languages, yeah. This is love, this is good, this is loving, yeah. Thank you, like, always. And here, well, there are other words. It's got, wall, same. We have two different sets of words, and we can compare. We can compare even when we make a query. So we make a query, age 45, and we say the people of 45, basically, the males are from Spain, and the females from Philadelphia. Yeah? And here it is the words they use. We see differences, yeah? Maybe the difference is because of the origin, maybe, yeah? We could select men from, or age 45, I'm from Spain, and see the difference between men and women. women. Well, once we have the data, we can also make some drawings. Yeah? This is the volume by time. So not by age, sorry. This is age. This is the 25, 30, etc. And this is the same, but drawing as a pyramid, populational pyramid. And this is the volume by time, yeah? By men and by women. Men, women, men, women, yeah? So we can draw it. But also the drawings, we can include the reference. So we make a search. We search for Mexico, and we see the drawings. Well, this is the global result, and this is the result of the query. This is the global result, and this is the result for the query. So we can compare. But also this is data. We are not differentiating. We don't see, here we see the difference in volume, but, well, maybe here there's a spot, yeah? You can see that here there's a difference. And maybe something strange here, also that one. But it's difficult to measure which are the differences. OK, we can make a different graphic. And not only put the volume, this is for males, this is for females, and here we can compare the dotted line is the difference between one gender and the other one. So when one has the minimum, the other one has the maximum, because we have to split the data between two groups. So here, clearly, looking at the dotted line, we can see that there are a lot of women in the 80s and a few men, yeah? And also here, there are less men that are 15 and more women. And the same about time. Yeah, well, here there are a few differences. But also we can apply a query. So we look at the people from Mexico, and what we were looking before on a text cloud, now we can view it on a graphic, yeah, and we can see the differences on age. Every time here there's something that goes down, here it should be, well, not. Now the correspondence is not so clear because we have selected only the people from Mexico, and there's the global statistics and then the difference between the two groups. Yeah? So here clearly, even that this is flat, it means that, well, in the flat, because there are so many people at this age and so few people at this age, but it gives us an idea that here it happens something, yeah? Because there's a lot of people in Mexico of males of this age. Yeah? Also, for example, even that this curve is influenced by the global evolution of the MySpace, because here at the beginning of, I think, it's not the year here. This was the beginning of 2007 when they started the Spanish forums, and this is at the end of 2008 when MySpace began to go down. Yeah. So this is the evolution of the forums. And we want to see if the evolution of the people of Mexico is similar to the evolution of forums. And we can see that there's a peak here. So this is something more related to Mexico than to the global evolution. How we did that? Well, we took Ajax-Solr, and we did some improvements on it. If we think on how many of you have ever used Ajax-Solr? No? Well, it's good to make fast interfaces just to deal with the data. And the idea is that you have a query, you send an Ajax query, you get a result set, you put it in the interface. The interface is easy to click on the different elements, so you can change the query. When you change the query, it will resend it to Solr, send a new result set, and show it again. But you have a single query and a single result set, and you are always showing the last data. What we have done is to add more and more result sets and to add more and more queries. So now when we show the data, we can compare between the different result sets, and we can keep the different queries. So the extension is basically to work with multiple sets. Yeah? Each set has its own query. And, well, multiple data sets. Yeah? Each set has its own query. And a query, it can be composed by different query terms. And also, a query has a basic, a set can have a basic fixed query. So for example, you say, OK, I have set 0 and set 1. Yeah, I have set 0. Set 0 is something like a base query. And then we can have set 1, set 2, for example. This is for male. This is for female. And we can put a filter as a basic of the set. And then every time I add a query, I can have some kind of copy from one set to another set. So when I add a query here, it will copy here, and it will generate the query for that set and the query for that set. And the widgets, which usually are attached to the full result set, can be attached to the different sets, set 1 or set 2, or to set 0 when they are used to compare the data in set 1, set 2, maybe set 3, set 4. Yeah, I'm going to show you an example of using different data sets. The idea, basic idea is that when every time you add a term to the query, it can be spread to the different data sets. When you clear the query, only those ones that have been added are deleted, but not the basic ones. So you keep the basic query for the different sets. And the widgets that don't work with a single result set, but they can compare the data from the different result sets. Before I'm going to the row up, let me show you a demo. Well, this is the one about the statistics. Yeah, we have the full set, so I can select an age. Hope it will work. Yeah, it works. So the people, which is about 100 years old, they talk about MySpace, they do it on the dog, PD. They are basically females and from these places. Yeah. Oh, sorry. You can delete. And we can say, OK, who says K? And we get that basically are males from these ages, yeah, and from these countries. But if we look at the difference, when we have two different sets, then the queries, we are always getting the difference between male and female. So as we saw, right, you can say, just put, for example, siempre, who uses siempre. Then here, siempre will appear. This is something that we should remove. But here we see the differences between countries. We see the differences between ages. Well, this is some debugging numbers. Just to know the data. Or we can add a country. And, well, there's a few people of this country, yeah? So there's a few things to drill down here. You can look at people from Spain. There's a lot of... I can say, OK, the people from Spain, which are 20. So we see the different language, if they use different language with kind of things they say, and see the differences. Well, this is for male and female, but also we can apply that to different sets of data. Oh, I'm sorry. Here's another example. We have 4 sets of data, or 4 basic queries. We have a query which is the last hour, a query which is the last day, last week, and last month. So we do an RS feed of news of Spanish newspapers. So I think there's a query now here. Yes, sometimes the query doesn't appear here, something. So we have some widgets that are just some graphics. Well, the computer is not very fast. And here it's volume. Here it's the different section of the newspaper that I think, as I started later, it was the update. And here are the different sources. Yeah, so I can select data by source. And here are the name entities, the bigrams, and the names that are in the title. And here we have some verbs and some adjectives. And the first is the last hour from yesterday, the last week, and the last month. So if we look at the last week, for example, we have El Hierro, which is the Canarian island where there is the volcano. From yesterday, they were talking about ETA, which was a peace meeting in Bilbao. And here is what had been happening the last hour. Yeah? So, well, something about eating. Oops. I don't know what happened. Has reload. Maybe it's the query. No, it has reload the page. Shouldn't do that. And those are the bigrams that appear. Bigrams are just combinations of words that we use natural language processing just to extract the names, verbs, and adjectives, and we combine them. And we can look at any of them. Well, I saw in the morning it was about Fukushima. Now I see that Fukushima is not from the last hour. But for example, it's something about the Kurds. So if we select this word, because we see what's going about the last time, the last month, I think more or less here it's, I think it's here it's, oh. I think every time I took this one, it loads the data. So it's something is happening with the PKK, which is the Turkish, yeah? Or something is happening in Iraq about Turkey, and then we can see the time evolution, and also we can go down and see the last news. Yeah. Also, we can change from one result set, which is the last hour, from yesterday, and the last week. So here, when you do from yesterday, it says the ones related from yesterday, and we say the last month. So we can move from one set to another set, just looking at differences at the result sets. OK. So the basic idea I wanted to present is that facets are interesting. They give some statistics which give an idea of what's on the data, but they don't give information. The information is basically on the differences. And AjaxSolr can be adapted to manage not just facets, but the differences between facets. Of course, if we have charts and graphics, this can help us to have an overview of the data, to change from data to information. And this is one of the key points. Basically, the code you have seen, it's under development, because we did that for the previous version of Solr JavaScript, and they have discontinued that. They have moved to AjaxSolr, and now we're developing it for AjaxSolr 4.0. So I hope to have it really soon and to put it at least in my page and the correct links in the Ajax or the Solr wiki and user space. Yeah. So thank you very much.